Let's look at the graph of y equal to cosine x. I want to start by creating a table of values for x and y using my unit circle. We know that cosine of 0 is 1, cosine of pi over 6 is square root of 3 over 2, cosine of pi over 3 is 1/2, cosine of pi over 2 is 0, cosine of 2 pi over 3 is negative 1/2, cosine of 5 pi over 6 is negative square root of 3 over 2, cosine of pi is negative 1, and before I continue, between 0 and pi over 2, we see that y decreases from 1 to 0. Between pi over 2 and pi, we can see that it decreases from 0 to negative 1. If I continue, we have that cosine of 7 pi over 6 is minus square root of 3 over 2. Cosine of 4 pi over 3 is minus 1/2. Cosine of 3 pi over 2 is 0. Cosine of 5 pi over 3 is 1/2. Cosine of 11 pi over 6 is square root of 3 over 2. And finally, cosine of 2 pi is 1. So in this case, we can see that between pi and 3 pi over 2, y is increasing from negative 1 to 0. And between 3 pi over 2 and 1, y is increasing from 0 to 1. So let's look at graphing these points. Here we have all of the points graphed. We can see that y decreases from 1 to 0, and then from 0 to negative 1. It then increases from negative 1 to 0, and 0 to 1. And since this is a periodic function, this pattern here should continue indefinitely. So if I connect my dots, we can see what the graph of cosine looks like. We can see that the domain is negative infinity to infinity, since any input is valid along the x-axis. The range is going to be between negative 1 and 1, the highest and lowest value on this curve. We can also see that the period is 2 pi. This does repeat from 0 to 2 pi repeatedly. And this is an even function, meaning that this y-axis acts as a mirror. It's the same on both the left and the right side of the y-axis, and this makes it even.